Now, I have confirmed that this is a centrifugal specifically, and we're not seeing any changes on the actual process side of this. What I think is happening is your machine is optimizing and it's doing what it's supposed to with this. The PRV and the VSD work in unison together. In a perfect world, we will run the PRV as open as possible, so full open, with the VSD as slow as possible, so slow. This is a perfect world because at this point, our impeller is at its maximum mechanical efficiency when the IGVs are fully open feeding into that impeller. But then our VSD is at its maximum efficiency when it's having to output the least amount of current possible, or in which we do that by lowering the hertz output to the motor. So this is an ideal position. And part of the staging of these chillers that you'll run into is the PRV. Stage 1, chiller turns on, PRVs are closed, and so we're going to go 0%, and you're going to have a minimum hertz, which is, if we're going with a 60 hertz machine, so I think, what is it, 30 hertz, I think? Okay, so this would be, say, your startup conditions. And then we want to start increasing load to meet leaving water set point. So then we will slowly work our PRV up to 100%. Okay, let's just say we don't have any surging concerns. And we will still maintain this 30 hertz right here if we can. We'll stay as close to it as we can. Yours may not be literally 30 hertz, just as an example. Let's just say that was our minimum hertz programmed in for your machine. The only reason we're going to increase hertz before we hit 100% or PRV is if we're having a lift concern. So if per our surge map or our stall sensor, if any of those are detecting a possible surge or stall condition, then what we will do is we'll pause increasing the PRV and we'll step up our hertz. So if we don't hit this, let's say we made it to 80% PRV. If I could write today, that'd be awesome. Let's say we made it to 80%. And then at 80%, we started to see some instability. So then we would end up seeing the hertz, say, increase to 35 hertz. Once we hit 35 hertz, we overcome that lift condition, and then we could increase a little bit higher and then make it to 100% IGV at 35 hertz. Now, if we hit this point with 100% IGV and 35 hertz, but we still haven't met leaving water set point, let's say we're at 47 degrees leaving water and we're trying to hit 45, then we will start to increase the hertz instead of the PRV. Now, this is a proper staging sequence, but depending on these circumstances, we may have a situation where we can't increase the PRV to 100% due to whatever load conditions, specifically lift conditions. Our lift may be in a position, and I'm covering up my thing here, aren't I? Our lift may be in a position to where we can't actually get the PRV that high, because if we did, we would go into a surge, and the chiller is monitoring this and it knows that, and it's not going to intentionally surge itself. So then we'll just see the speed increase. What I would expect in your situation is your machine is operating exactly like it should, and that when it goes time to unload and run at a minimum state, you want to see that PRV go to 100%. And then you want to see that VSD modulate up and down. And when you're able to do that, you're allowing that chiller to run at its maximum efficiency it's capable of doing. And it's intentional. And that's why you don't see the leaving water set point fluctuate. Or not the set point, but the actual leaving water temperature. The leaving water temperature stays consistent. It's at set point, but the PRV is full open. This is why. This is a good thing. So I would encourage you, this may be a good test for today. In a normal operating state during the day when it's got load and it's having to deal with more lift issues because Our condenser water is going to have more trouble getting down to temperature. Like, all those factors are going to be true. Go see what your speed is under those conditions. And then the next morning when y'all come in, because that's what it sounds like. It sounds like when you come in the mornings, you're seeing the PRVs running really high. So in that, then go see what your VSD is doing and see if maybe the VSD is lower. Maybe. Because part of what will happen is when we do deal with a high lift condition, the PRV will close and the VSD will speed up, which, especially during this time of year, this is when we're going to deal with higher lift conditions, because our condenser water typically is going to be increasing and we're going to have higher loads. Those things in unison could push our lift conditions higher, especially the condenser water aspect of it. So if we can get in the evenings when the condenser water drops down and our load reduces, we have a lower total lift, then that chiller may be able to run in a way that it can't run during normal operating hours.